Using the law of sine, we need to show that in a triangle ABC, A cosine A plus B cosine B plus C cosine C, that's equals to either 2A sine B sine C or 2B sine C sine A or 2C sine A sine B. Let us begin. Now what we'll do, we'll start from the left hand side, but before that, let's state the law of sine. So we consider an acute angle triangle ABC. The side opposite to angle A is represented by the letter A in lowercase. The side opposite to B, angle B and angle C, is represented by B and C in lowercase as well. Now the law of sine states that the ratio of side A to that of sine of the angle opposite to it, which is angle A, will be equals to the ratio of side B to that of the sine of the angle opposite to B. So that's angle B. And this is also equals to the ratio of side C to that of the sine of the angle opposite to it. So that's the law of sine. Now what we'll do, in order to solve this problem, we're going to suppose that let these three ratios be equals to a constant lambda. Now in doing so, we can rewrite A as lambda times sine A. Then B will be equals to lambda times sine B. And C will be equals to lambda times sine C. Now we'll start from the left hand side. So here we have A times cosine A. So A will be replaced with lambda times sine A multiplied to cosine A. Then coming to the second term, B will be replaced with lambda times sine B multiplied to cosine B. Then the third term will be lambda times sine C. We are replacing C with lambda sine C multiplied to cosine C. Now what we'll do? To each of the terms, we're going to multiply by 2, and since 2 is an extra factor, we'll also have to divide by 2. So that means we'll take lambda over 2 as the common factor, and each terms are then going to become 2 times sine A times cosine A plus 2 times sine B times cosine B. And the third term will be 2 times sine C times cosine C. Now we are multiplying each term with 2 because we know for a fact, we know that 2 times sine theta times cosine theta. So that's the formula for sine 2 theta. So using this, we are going to get lambda over 2 whole multiplied to sine 2a plus sine 2b plus sine 2c. So we're going to label this as number 1 because we'll have to come back to this again. For the time being, what we'll do, we'll take sine 2a and add it to sine 2b. Here, we're going to use a formula. We know that sine theta, when added to another sine of another angle phi, so this sum is equals to 2 times sine theta plus phi divided by 2 multiplied to cosine of theta minus phi over 2. Fine. So let's do that. Let's substitute this value here. So we are going to get lambda over 2 multiplied to, so sine 2a plus sine 2b will be equals to 2 times sine. So here we have 2a plus 2b divided by 2. That's going to give us a plus b multiplied to cosine. So we're going to take 2a and subtract from it 2b and divide by 2. That will give us a minus b plus we have sine 2c. So sine 2c is 2 times sine c times cosine c. So here we're using this formula. Now what we can do here, we can now rewrite sine a plus b. That's because we know for a fact that the sum of the interior angles of a triangle adds up to 180 degrees. So we have a plus b plus c. So that's equals to pi. So a plus b will be also equivalent to pi minus c. So if we take the sine of a plus b, so that will be equals to sine of pi minus c. Now what's sine pi minus c? So sine pi minus c is sine c. So we can say that sine of a plus b is also equivalent to sine c. So what we'll do, we'll replace this value of sine a plus b with sine c, and this is going to give us lambda over 2 multiplied to 2 times sine c multiplied to cosine of a minus b plus 2 times sine c. Now we'll are also going to rewrite cosine of c. So we are going to take this a plus b equals to pi minus c. Now this time we're going to take the cosine on both sides. So we have cosine of a plus b. This will be equals to cosine of pi minus c. So what is the value of cosine of pi minus c? So that's negative cosine C. So we can say that cosine of A plus B will be negative cosine C, or we can say that cosine of C equals to negative of cosine of A plus B. Fine. So we'll substitute this value here. So we are going to now get 2 sine C will be multiplied to cosine C. So we're going to replace cosine C with negative cosine of A plus B. Fine. Now what we can do, we can take 2 sine C as the common factor from the two terms. We can pull it out of the parentheses and combine with lambda over 2. And that's going to give us lambda multiplied to sine C. Whole multiplied to, so we have cosine of A minus B. This is from the first term. And from the second term, we are left with negative cosine of A plus B. Now what we'll have to do, we'll have to combine these two, cosine of A minus B minus cosine of A plus B. So here we're going to use the fact that whenever we have cosine of theta minus cosine of phi, so that is equals to 2 times sine theta plus phi divided by 2 multiplied to sine phi minus theta over 2. So if we consider theta to be equivalent to A minus B and phi to be equivalent to A plus B, then this will get combined. This will combine with each other. So we have lambda times sine C multiplied to 2 times sine. So we have A minus B added to A plus B. So that leaves us with 2A divided by 2 is going to give us simply A. And then we have sine of B. Fine. So what we have obtained here is 2 times lambda sine C multiplied to sine A times sine B. Fine. So we're almost done with the proof. So we started out with A times cosine A plus B times cosine B plus C times cosine C, and we got that this result is equivalent to lambda sine A times sine B times sine C. So we're not quite there yet with our proof. Now what we'll do, this can be written in 3 different ways. So we can also rewrite it as 2 times lambda multiplied to sine A multiplied to sine B times sine C. So this is one way. The second way will be 2 times lambda times sine B multiplied to sine A times sine C. And the third way will be 2 times lambda multiplied to sine C whole multiplied to sine A times sine B. We are writing it because we have already defined the value for lambda sine A, lambda sine B and lambda sine C using the law of sines. So here we have this value. So that means we will now get, this will be equals to 2A sine B sine C. Or we have 2B sine A sine C. And third we have 2C sine A sine B. Hence we have successfully showed that A cosine A plus B cosine B plus C cosine C. So that could be either 2A sine B sine C or 2B sine A sine C or 2C sine A sine B. Hence proved.